Hello students, let us learn the Laplace transform of a function divided by t. So for any function f of t, if the Laplace transform of the function f of t is f of s, then the Laplace transform of f of t divided by t is equal to integration from s to infinity of f of s ds. So whenever a function is divided by t, then recognize what is f of t, then evaluate the Laplace transform of this f of t, denote it by f of s, then the Laplace transform of f of t divided by t will be given by integrating that f of s within the limits s to infinity. Now let us go for an example. Find the Laplace transform of cos at minus cos bt divided by t. So here we need the Laplace transform of the function cos at minus cos bt, which is divided by t. So leaving this divided by t term, the remaining function will consider it as f of t. So f of t is cos at minus cos bt. Let us find its Laplace transform. Laplace transform of cos at, it is a s divided by s square plus a square. Then Laplace transform of cos bt, it is s divided by s square plus b square. Now this becomes our f of s. Now to find the Laplace transform of f of t by t, we need to integrate this f of s within the limits s to infinity. So integration from s to infinity of this function f of s, that is s upon s square plus a square minus s upon s square plus b square ds. Integration of s upon s square plus a square will be in the form of f dash s upon f of s if we multiply the numerator by 2. That is because derivative of s square is 2s here. To get it in that form, we'll multiply the numerator by 2 and hence divide by 2. In the second term also, derivative of s square is 2s. We don't have this 2. So wholly this is multiplied by 2 and divided by 2. Now we have the integration of 2s divided by s square plus a square, which is in the form of f dash s upon f of s, is log of s square plus a square. And here minus again integration of similar term 2s divided by s square plus b square. It is log of s square plus b square. The limits are from s to infinity. Now this is in the form of log a minus log b. We'll write it as log a by b. If we put directly the limit infinity, it takes indeterminate form. So what we do is take s square common from the numerator as well as denominator so that s square cancels. Now if we put infinity here in the wherever s is there, then we get 1 plus anything divided by infinity, that is 0. And in the denominator again it is 1 plus 0. Then we can simplify. So we'll be taking s square outside. Then what remains is log of 1 plus 0 divided by again it is 1 plus 0 minus when we put s as s itself, the function remains same. But log 1 is 0 again minus log. If we take LCM, it gives us s square plus a square divided by s square, again s square plus b square whole divided by s square. The denominator of both will get cancelled. We have only log of s square plus a square divided by s square plus b square. But outside we have here minus 1 by 2. This minus sign will be multiplied here and we'll write the reciprocal of this term. M log a can be written as log a raised to m. So by that, it will take the reciprocal of this term. Again, 1 by 2 is there. If you take it to as log of s square plus b square divided by s square plus a square raised to half, it can be written as root of s square plus b square divided by s square plus a square. So that is the Laplace transform of the given function. Let us consider one more example. Find the Laplace transform of 1 minus e raised to minus t whole divided by t. So we need to find the Laplace transform of this function where we have a function divided by t. So let us write the function first. F of t, it is 1 minus e raised to minus t. Now we'll find the Laplace transform of this. Laplace transform of 1 is 1 by s. Laplace transform of e raised to minus t, it is 1 divided by s plus 1 because a is minus 1. We get s plus 1. Now we have got our f of s. Now the Laplace transform of a function divided by t will be obtained by taking the integral of f of s between the limits s to infinity. So let us evaluate the integral of this f of s within the limits s to infinity. Integration of 1 by s is log s. Integration of 1 upon s plus 1 is log of s plus 1. Limits are s to infinity. Now again we have log a minus log b, which will be written as log a by b. We cannot directly put again log infinity for s because log of infinity by infinity it becomes. So we'll take s common from the denominator, which cancels with the numerator s, and we are remained with log of 1 divided by 1 plus 1 by s. Now the limits are from s to infinity here. If we put infinity now, this term becomes 0. So we are remained with log of 1 minus lower limit s. If we put, the function remains same. Log 1 is 0 again. So we are remained with minus log. Taking LCM here, it becomes s plus 1. S comes to the numerator. So it is s divided by s plus 1. Now minus sign is there outside. M log a will be written as log a raised to m. So that becomes s upon s plus 1 raised to minus 1. Then we need to take the reciprocal of this. So the answer is log of s plus 1 divided by s. Thank you.